Hello everyone. So now we will see example of Dijkstra's algorithm. I will explain you first two iterations of this. So let's start executing this algorithm on this graph. That is, this is a directed graph where we want to find out shortest distance of all the vertices from source A. So initially, as per the init single source function, we'll set d value of all the vertices to infinity and parent we are setting to nil. D value of source vertex is set to 0. So we have this D array where we are setting D value of all the vertices to infinity. Let's say this is A, B, C, D. As A is a source, we are setting its D value to 0, and for remaining vertices we are setting it to infinity. After returning back from the single source, S we are setting to null, and in the priority queue we are inserting all the vertices. So S is a set which is initially empty. Now as per this Q is also going to have these values of the vertices. So as per this algorithm, while Q is not empty, we are extracting a vertex whose D value is minimum. So if you are observing D value of all the vertices except A is infinity, so the vertex with minimum D value is A, that we will extract and we will store that in U. So it is U is equal to A. Then as per this iteration, we have to add this S, A in U. We have to add this U in S, so we have added A in S. Now we have to apply, we have to find out which are the adjacent vertices of A. So we'll write this adjacent vertices of A. So from this graph, we know that adjacent vertices of A are B and C. So we'll add them in this set A, it is B and C. So for each vertex, we'll apply the iteration. So V is equal to, assume the first adjacent vertex as B. We are calling a function that is relax U, V and W. So as per the relax function, our V is the B and U is A. So we'll find out this distance of B. If it is greater than distance of A plus weight of AB, then we'll modify this and we'll set the parent of B as A. So if we are observing distance of B, is it greater than distance of A plus weight of AB? So if we are observing distance of B is infinity and distance of A is 0 and the weight of AB from the graph is 3. So if this is true, then we are modifying distance of B to 3 and we are setting parent of B as A. It means that B is reachable with a minimum distance of 3 from A. Therefore, A is parent of B. So as per this modification, we'll change this D array and we'll modify this infinity value to 3. Then again we'll go back and we'll consider next adjacent of A, that is C. So consider C. And again we'll apply that relax function, that is distance of C if it is greater than distance of A plus weight of AC. So if you are observing distance of C is infinity and distance of A is 0 plus weight of AC, from this graph weight of AC is 1. So this equality is true, therefore we modify the distance of C to 1 and we are setting parent of C to A. That is, C is reachable with a minimum distance of 1 from A. So this modification we are going to do on this array D. So distance of C get modified to 1. Now this was the first iteration of U, where U extracted mean Q from the Q is A. Now again we'll repeat this, as Q is not empty, we just have extracted A. So again in the Q we have different values. So that is, from Q we have extracted, we have A, we have deleted. We still have B, C, D and E. So as per their values, B's value is 3, C value is 1, D is infinity, E is infinity. So from this extract mean Q, so the vertex with minimum D value, that is C, is extracted in U. So U is equal to C. Now again we'll add this S is equal to S union U. So S get union, that is we already added A, now C gets added. Now it is saying that we have to consider all the adjacent vertices of C. So we'll find out adjacent vertices of C from the graph. So if you are observing adjacent vertices of C are B and D. So we'll consider one vertex at a time. So it is B and D. So first consider B. So again we'll apply that relax function. So it is saying that if distance of B, if it is greater than distance of C plus weight of CB. So distance of B is 3. So if 3 is greater than distance of C, we have just calculated as 1 plus weight of CB. So from graph it is 7. So this equality is not true. So will not change the distance of B. It means that B is not reachable with minimum distance from C. It was already reachable with minimum distance from A. So will not modify this D value of B. Next adjacent vertex is D. So again we'll find out distance of D. Is it greater than distance of C plus weight of CD? So distance of D, weight of CD is 8 and distance of D from the D is infinity. If infinity is greater than 1 plus, as we know distance of CD is 8. So this is true. Therefore D value of D we are setting it to 9 and parent of D we are setting it to C. That is D is reachable with minimum distance of 9 from C. Initially it was infinity and now we got the distance of D as 9. So this way we have modified this D array. So from this Q we have now deleted C. Now the D value gets changed from infinity to 9. Again apply the same iteration. So in the next iteration after applying mean Q, B is extracted as it has having minimum value. B is having 3, D is having 9, E is infinity. So B get extracted. Now we'll find out which are the adjacent vertices of B and we'll apply that relax function on each of these adjacent vertices. So we'll get the distance as, now after extracting B, we'll get the minimum distance of E with 3 plus 1, that is 4, and D's initial distance was 9 plus 9. But as we have invented a new vertex, that is B, the new distance of D will be 5 plus 3. So let's consider that B get extracted. Now adjacent vertices of B are E and D. So first we'll consider D. We'll find out distance of D. Distance of D is greater than distance of B. We have to remove this B plus weight of B comma D. So initial distance of D is 9 and distance of B is 3 plus weight of B D age is 5. So 9 is greater than 8. So new distance of D gets modified to 8 and distance of E gets modified from infinity to, as initially E is at distance of infinity, but as we have invented B, the distance will be 3 plus 1, that is 4. So new distance of E will be 4. So next time, as we have to modify these values in the array Q, so 9 gets modified to 8 and E gets modified to 4. So next time, and the parent of E will be B. This we have to note it down. Parent of C will be A. This we have to note it down. And the parent of B is still A. Parent of B is still A, as we have not modified the distance of B. So next time again E becomes 4 and D becomes 8. So if we are observing shortest distance of A to C, that will be this will be the final answer. A becomes the parent of C from this graph. So we'll get the shortest distance as A to C is 1, A to C is 1, A to B is 3, minimum distance. So we'll write down A to C is 1, A to B is 3. Now A to D. So as we have found out that B is the parent of D, because from C it was at a distance of 9, but due to invention of B we get distance of D as 8. So parent of D is B and parent of B is A. So the shortest distance of D from A will be 5 plus 3, that is A. So it is A, intermediate vertex is B, and then D. That will give you a distance as 8. And again now we are left with E. So if you are observing, E's parent is B. So shortest distance of E will be 3 plus 1, that is 4, via intermediate vertex. So this is the final answer of Dijkstra's algorithm, where we have found out shortest distance of all the vertices from source A.